Okay, we're looking at compound interest problems in this section. If you take a look at the try these, it says calculate to 2 decimal places. Really, this is learning how to use your calculator properly, and then this will end up being some of the calculations that you might find in these questions. So if you have a graphing calculator or a scientific calculator that shows what you're entering, like it shows brackets, it shows an exponent key, fractions, that kind of thing, then one way of doing it is to just enter this as a fraction. So on a TI, that's alpha y equals, and then number 1, and you'll see the fraction. On a Casio, it is the fraction looking key, looks like an A with B over C. And then we'll do what to do if you don't see don't have these capabilities on your calculator. So I'll enter 500, cursor down, bracket 1 plus 0.1, close the bracket to the exponent 4, and then enter on that. Okay, and these are money questions, so that's why it says 2 decimal places. So take a look, it's 0.5067, so the 6 makes the 0 go up to a 1, so it's $341.51. $341.51. Okay, and I'll do the next one if you have just a normal calculator. So what you can do, most scientific have an exponent key, bracket key as well as exponent key. Actually, even without using brackets, if you think about order of operations, we do inside the brackets first. So 1 plus 0.1. Move this up so you can see it a bit better. Okay, so that's inside the brackets. Then we're going to raise that to the exponent 4. So you can do that on any calculator. Okay, and then what we're doing is we're taking 500 and dividing by that number. So then you go, you may need to write that down, and then go 500 divided by 1.4641. So you're kind of doing it in the order of operations steps, and you see the same thing, same answer. Okay, now we'll do it for the other question, 1,000. Oh, sorry, let's do it the long way. So let's do the inside the brackets, 1 plus 0.05, which you might be able to do in your head. It's 1.05. Then square it. So you can use the exponent key. Some calculators will just have a squared key, so we can square that. And then we'll go 1,000 divided by that number, 1.1025. And that will be $907.03. Oops. And then it's money, so make sure you have your dollar symbol. Okay, so the formula for compound interest is this formula here. So it says May is a cashier at a wallpaper store in Calgary. She invests in a savings account each month. The interest rate is 1.3% per year, compounded annually. Annually means yearly. After 2 years, one of May's monthly payments is worth $97.49. Okay, so what did she invest that month? So for this particular investment, like there are different, there's things called annuities that you invest in, and you can break it up into each investment. We're keeping it pretty straightforward. We're just looking at the compound interest formula for one investment. So she is, and what this A value is the amount that you have at the end of the investment. P is the principal, the amount that you invest. I is the interest rate for each compounding period. So in this case, yearly, because it's compounded annually. And N is the number of times it compounds. So the interest rate, we always have to put the decimal form. So 0.01. They've already done the 2 for us because it was in there for 2 years. And we're told that what it was worth at the end. So this isn't the interest. This is the final amount, A for amount. So $97.49. So she invested less than that, and then after 2 years, that's what it was worth. Oops, what did I forget here? It's 0.013. I didn't get the 3 in there. 0.013. Okay, so take a look. We're actually got to work backwards in this one. Sorry. Oh, there we go. It's got to go up a little bit. There we go. So how much did May invest in that month? So we need to figure out the value of all of this. And obviously, the final amount, we just copy that out. So you can get out your calculator and figure out, just a sec here. So 1 plus 0.013, so that's inside the brackets, and then we're raising that to the exponent 2, or squaring it. So I did it in 2 steps. So 1.026169. 1.026169. And so then it's just a solving equations question. You want to solve for P, so you got to divide $97.49 by 1.026169. Now it's already in your calculator. So enter $97.49 and divide by that answer. Now, if you have a graphing calculator, you can cursor up and copy it out. But if you have a scientific, you would just enter it. And it's basically 95. Okay. $95.00, which is $95. So not a whole lot of money because that interest rate is small, right? 1.3% is not a big interest rate, but $95, that's not a whole lot of money. If she could put in 3 times as much, she'd earn 3 times as much interest. The interest that was earned would be the difference between these 2 values, right? So it would be $2.49. Next one, they earn a little bit more interest. So it says Daisy wants to start saving for a party for her business in 5 years. The interest rate for Daisy's investment is 3.2% per year. Interest is compounded annually. How much does Daisy need to invest now to have $4,000 after 5 years? So now we're looking to calculate what the P value is. So what do we know? We know A is 4,000. Interest rate for compounding period, well, it says it's compounded annually. So it's just going to be that 3.2%, which is 0.032. Remember, you're always dividing by 100 to get it to not be in percent form. Number of compounding periods, well, it's yearly for 5 years. So N would be 5. Oh, cursor to the next page. How much money, the principal, does Daisy need to invest now? So that's, now we're looking for the P. And so here we're told the interest rate was, sorry, I gotta make sure, yeah, 3.2. So this is 0.03, oops. and the final amount was 4,000. Okay, so, and the exponent here was 5 years. So much like the last one, we're going to enter that into our calculator. And now maybe I'll do it all at once. So bracket 1.032, close the bracket to the exponent 5, and 1.17057. And there's more decimal places, but I'm just going to show that many. So now to get p by itself, we take 4,000 and divide by that. Okay, so in my calculator, I'm going to go 4,000 divide, copying that out, or I can, if you have the capability to go up and select it. So I'm just copying what I see. And that would be $3,417.13. Okay, so essentially, if we rounded to the nearest dollar, 3,417. So really, in those 5 years, she will have earned interest. The difference between 4,000 and 3,417 is what? $583, right? For just investing it. So that's a pretty good amount of interest. There's an interesting fact that if, suppose you know the interest rate and how long the compounding period is for your investment, you can use the rule of 72 to estimate how long it will take for it to double. Okay, so here, years to double. So if you had 1,000 and you wanted to know how long it would take for it to become $2,000, you take the value 72 and you divide by the annual interest rate as a percent. So James runs his own business as a locksmith. He's responsible for saving for his retirement. He invests in an RSP every year. 1 year he invests $3,000 at 3.6% per year, compounded annually. About how long will it take for James's money to double? So we know the interest rate, okay, and it's 3.6. The years to double then will be 72 divided by 3.6. So if we get out our calculator on that, 72 divided by 3.6, 20 years. Okay, no matter what he started with, but in this case he is starting with 3,000, so that means in 20 years it'll be 6,000. Yeah, 6,000. Another good relationship is 7 and 10. So if you can find an investment that earns you 7%, then it will take 10 years to double. If you can find an investment that is worth 10% per year, it'll only take 7 years to double. So that kind of makes sense. Double 3.6 is a little over 7, and so that means this would be half of 20 is 10 years. Okay, now we're just going to check that that estimate makes sense. So our principal is 3,000. Our interest rate is 0.036, and it's going to be in there for 20 years, we're saying. Okay, so now in our calculator, we can put this all in at once. So 3,000 bracket. And you can add that in your head, or go 1 plus 0.036, close the bracket, to the exponent 20 is what we're saying. And yeah, you can see it's a little more than 6,000. 6,085.78. 6,005.78. So the amount is about twice or double 3,000. So the estimate is 6,008. That's the actual value, I should say. So the estimate is about 6,000. Okay, so that's 1.6. That's the end of